What's up, guys? I'm doing a video for you from the last task of the last topic of Khan Academy AP Calculus AB, Contextual and Analytical Applications of Integration, Calculator Active. Very intense stuff here. You have to have a calculator for what we're doing, but it does come back down to just how to use an integral. The question I'm going to be answering right away is the temperature in a room changes at a rate of R of t equals the natural log of t plus 1 times sine of t degrees Celsius per hour. T is the time in hours, and also when t equals 1 hour, the temperature is 18 degrees Celsius. We're going to determine what the temperature is after t equals 3 hours. This is a cumulative problem, so the first thing you need to understand is that that formula, R of t, is a rate of change. And the integral of a rate of change is like the total amount, like the cumulative amount of distance traveled or money acquired, or in this case, temperature achieved over time. We're going to integrate from 1 to 3 because we know what the time, we know that at time t equals 1, the temperature is 18 degrees. So Celsius, by the way. So we're adding that 18 at the end of our integral function. I'm using Desmos because you should have access to Desmos. I'm just going to do a little quick type in here. I'm typing in the formula R of t. And, oh man, that's a really interesting looking graph there. Got some uniqueness to it. We're going to restrict it from 1 to 3 because that looks a little more boring, but we're restricting it from 1 to 3 because those are our limits of integration. Now, the nice thing about using a program like this is that I no longer have to type all of that function out. I can just type R of t and get an answer. Adding 18 at the end, my temperature at this time is now 19.571 degrees Celsius. I wanted to make sure that I showed that you could do this with the TI-84, gave you, the TI-84 user some love. So going to this one, if you notice that the math button down at option 9 where it says finite, you can take the numerical integral and get an answer. So from 1 to 3, we're going to evaluate the integral from 1 to 3. But I don't want to type all that stuff in multiple times. So I'm going to share with you a secret if you haven't learned it yet that you can do with the TI-84. I went into the y equals menu and I'm typing in that equation, the natural log I'm using x, not t, but typing in the natural log, and it's all that y1. I mean, a little zoom 6 would show me the same picture, but I already know that. Let's go back to the home screen. When you press the vars and then go to yvars and then go to function and then call up y1, boom, you have your function in there. It's going to do all that math for you, and a little clicky click of enter. Answer is 19.571. Again, that was vars, function, yvars, y1. You can do this as well in the TI-NSpire. A lot easier on the Inspire, less hidden stuff. I want to share with you some syntax error that might happen. I just typed it straight out. There's this notation that you have to specify the function. So a thing that you can do, a little cut and paste, copy paste, is that you can change an equal sign, and which means equality of value, into a define the function to be by using a colon equals. From this point on, R is a function and R of 2 spits out a number. So just like the previous one, just like Desmos, we're going to integrate a function from 1 to 3, the function R. Don't need to type it out anymore. And don't forget to add 18, and sure enough, there it is. You get 19.571. Well, I took those information, any of those methods, rounding to 3 decimals. That's typical for the AP test. Plugging that in to Khan Academy, got my points. Thanks for watching this video. I want to make sure that I shared with you that the key idea here behind this one, with some technology components, you're really just integrating. If it says I want the cumulative amount, integrate it. Know your limits of integration. In this case, it's not plus c, it's just adding that initial condition because all the area under the curve has been adjusted by some number. Thanks for watching. Thanks for doing some math with me, and see you on the next video. Thanks.